Hello everyone, we come back again. Thank you so much for coming back to watch the second part of this lesson. So as we mentioned before, we just introduced the two methods, SSS and also SAS. So this is a just short way to introduce these two methods here. And also now we are going to look at some example to see, can we prove this triangle is congruent? If so, what method will you use? So let's look at the graph here. You can definitely pause the video to see what's your idea, and later you can compare your answer with mine. So this one, if you check this carefully, um, according to the graph, the marks are provided on the picture. We know, let's use different color. We know this side is congruent to this one, right? And also I know this side is congruent to this one. So sometimes some student might argue, we have only two pair sides. There's no method called SS. Then how can I prove this? So do not forget, the very last one is the one in the middle, which they shared by the two triangles. If they shared, of course, they both have JK. Of course, this one is going to be congruent because it is itself, right? So that's why the answer is yes, they are congruent. And also we can create a congruent statement. We can write down, and also, you know what, let's do that. Let's write down all the evidence we have. So we have HK congruent to KL. We also have HJ congruent to JL. We also have the one in the middle, JK. Some student might argue JK is congruent to what? Yes, it's congruent to itself, so it's JK. So that's why triangle HKJ, again, when we create a statement, we have to be very careful about the order. So HKJ, to matching this is going to be LKJ. They're congruent by what method we have to use? Yes, we have 1, 2, 3 sides, so it's SSS. Okay, so that's basically this is our evidence. And this is our method. Okay, so that's how do we do this one. Let's check another one. Check this one again. Pause the video to see what's your idea. Do you think we can prove, or we do not have enough information? You can definitely jot down your idea on the paper to see if you have the same answer as mine. Okay, let's check what information we have here. We know I have, according to the marks, BC is congruent to CE here. So let's write down BC is congruent to CE. They have 1 marks, right? And also we have AC is congruent to CD. So AC is congruent to CD. What other information do we have? Some students already noticed the angle. And if you really pause here, think about this. What type of angle we are talking about? Yes, you're right. It's vertical angle, and we know vertical angle. Let's write down that. Vertical angles are always congruent. Okay, so next I'm going to write down angle. Some student might write down angle C is congruent to angle C. I would not write like this way. You know why? Because as you can see, there's a multiple angles intersect as C. So I'm going to indicate it very clearly. I'm going to write down as angle ACB is congruent to angle ECD. Please make sure the vertex in the middle, or you can even label this as angle 1 and angle 2, or you can write down as angle 1 congruent to angle 2. So we have all the information here. Let's write down the final congruent statement. So triangle ABC is congruent to triangle. Please make sure it always matches angle. So A is matching to D, so it's D. B is matching to E, so it's DEC. By what method we have? Yes, you're right. So side, angle, side. Okay, so that's, again, we provide, this is our evidence, and this is our final conclusion. Now, let's check another two examples here. That will be the final examples. Let's check the left graph. Based on the picture we have here, based on the marks we have here, we have one side of BC is congruent to EF, and also we have AB is congruent to DE. We also have a angle. Angle C is angle A. So some student might quickly think, oh, I have side, angle, side. But do not forget, when we mention we use side, angle, side, we have to use included angle. Keyword, included angle. If you check the position of this angle very, very carefully, this angle is in the corner on the side. I have these two sides here. So in order to use include angle, this angle should be here. But do I have any information for that? No, we don't. So that's why for this one, we cannot prove it. Not enough information. So no, we cannot prove these two triangles are congruent. Okay? You cannot say, hey, it look like they're exactly the same. Again, do not assume. This is not going to work for proving. Let's check another one. So we have one side congruent to this. We also have another side congruent to this. Only two sides here, and we don't know anything about the third one. You cannot say, hey, then PQ must be congruent to QS. Again, do not assume it because we do not have the information. And some student might say, hold on, I know we have congruent angles because they are vertical angles. If you have to this conclusion, then congratulations, your observation is correct. We do have vertical angles, but my question is, can I use SAS to prove it? Again, if you think very carefully, now you probably know, no, we can't. Why? Because this angle is not included. What is included? Meaning, let's check the two sides. I have these two sides. So included must be here, right? Do I have this angle information? No, we don't. You cannot say, again, it looked like T is congruent to R. We do not have that information. So that's why, again, not enough information. And no, we cannot prove they are congruent. Okay, so that's all the example I want to share with you. I hope this video is helpful. Thank you so much for watching this video and study the lesson with me. See you soon, everyone.